In this example, it is asked to evaluate the line integral along the curve C of the vector field F capital dotted with dr, where the vector field F capital is equal to sine x times the vector I plus cosine y times the vector j plus x times z times the vector k. And the curve C is given by the vector function r of t that is equal to t to the third times the vector I minus t to the squared times the vector j plus t times the vector k, where 0 is less or equal to t less or equal to 1. From the vector function, we get that x of t is equal to t to the third. Then y of t is equal to negative t to the square, and z of t is equal to t. So from that, we can get that the derivative of x with respect to t is equal to 3t to the square. Derivative of y with respect to t is equal to negative 2t, and derivative of z with respect to t is equal to 1. Therefore, from all that, we can formulate the dr, which is equal to the tangent vector times dt. So that is equal to the vector, the tangent vector is equal to the vector with components x prime of t, y prime of t, and z prime of t times dt. So that is equal, x prime of t is equal to 3t to the square, y prime of t is equal to negative 2t, and z prime of t is equal to 1 times dt. And we can also evaluate the vector field F capital at the vector function, which is equal to sine of x. X is equal to t to the third, so sine of t to the third times the vector I, plus cosine of y is equal to negative t to the square times the vector j. And then we have plus x times z. X is equal to t to the third, z is equal to t, so we have t to the fourth times the vector k. So that is equal to the vector with components, sine t to the third, cosine. Now the cosine of negative t to the square, since the cosine is an even function, the cosine of the negative t to the square can be written as cosine of t to the square. So for an even function, we have that f of negative x is equal to f of x. Therefore, the cosine of the negative t to the square is equal to cosine of t to the square. And then the z component is equal to t to the fourth. Therefore, if we evaluate the line integral along the curve C of the vector field F capital, evaluated as a vector function dotted with dr, this is equal to the integral from 0 up to 1. The vector field is equal to the vector with components sine t to the third, cosine t to the square, and t to the fourth, dotted with dr, which is equal to the vector with components 3t to the square, negative 2t, and 1 times dt. So that is equal to the integral from 0 up to 1. And if we now evaluate the dot product, we'll have 3t to the square times sine t to the third minus 2t times cosine of t to the square, and then plus t to the fourth times dt. So for the first term of the integral, we'll have to do a u substitution. Substituting u with t to the third, we'll have that du is equal to 3t to the square dt. So therefore, 1/3 du is equal to t to the square dt. And therefore, from all that, we get that the integral of sine u du is equal to negative cosine u plus c. So that is equal to the negative cosine. U is equal to t to the third, so cosine negative cosine t to the third, and then plus c. So this is for the first term of the integral. Then for the integral of the negative 2t cosine t to the square, we can do another substitution, substituting v to be equal to t to the square. We'll have that 1/2 dv is equal to t times dt. And therefore we have the integral of negative 2 times 1/2 cosine of v dv will be equal to the negative sine of v plus c. So that is equal to the negative sine of t to the square plus c. So with these two substitutions, we go back to the integral. So we have the integral from 0 up to 1. And essentially, since we have done actually the substitution, we can go directly and say that we have the negative cosine t to the third for the first term minus the sine t to the square for the second term. And then we have the integral of t to the fourth dt, which will give us 1 plus 1/5 t to the fifth. And we evaluate that between 0 and 1. So that is equal, for t is equal to 1, we have a negative cosine of 1 minus sine of 1 plus 1/5. And then we have minus, for t equals to 0, we have a negative cosine of 0 minus sine of 0 plus 0. So that gives us a negative cosine of 1 minus sine of 1 plus 1/5. And then we have, for the cosine of 0, we have that this is equal to 1. So minus the negative 1 will give us a plus 1. The sine of 0 is equal to 0. So simplifying, we end up with 6/5 minus cosine of 1 minus sine of 1.